Hello everyone. I am Dr. P. Magesh Kumar from the Department of Civil Engineering, K.S.Rangasamy College of Technology. Today's lecture focuses on the topic water quality parameters and standards. Whether we are dealing with drinking water supply or wastewater treatment or environmental conservation, assessing the water quality is the first step towards protecting public health and the environment. Water in its purest form is simply H2O, but in reality it always contains some level of impurities. These can come from natural sources like soil, rock, or human activities such as domestic sewage, agriculture, and industry. These impurities in water are generally classified into three types. Physical impurities. These affect the sensory properties of water like how it looks, smells, or feels. Chemical impurities include dissolved salts, metals, nutrients, and gases, some of which are harmful in excess. And the biological impurities consist of microorganisms like bacteria, virus, protozoa, and parasitic worms. So, understanding these categories helps us in choosing the right water treatment methods. So now let us explore physical parameters. These parameters often affect the aesthetic quality of water and are in the first indicator of contamination. Suspended solids, turbidity, color, taste and odor, and temperature. The suspended solids. These are visible particles such as silt, clay, algae, or organic matter that do not dissolve. They make water appear turbid and reduce light penetration, affecting the aquatic ecosystem. So, this can be measured by the filtration technique. And the turbidity, this is a direct measure of how cloudy the water is. It's usually measured in NTU nephelometric turbidity units or JTU or Baylis turbidimeter. High turbidity can indicate microbial contamination or sediment runoff. Next, color. Natural water may have a yellowish or brownish tinge due to decaying leaves or iron content. A sudden change in color can be a red flag for pollution. So, the color matching technique or TCU, true color unit, is used to measure the color. The taste and odor. These are qualitative parameters. For instance, hydrogen sulfide gives water a rotten egg smell, and the metallic taste may indicate high levels of iron and copper. So, gas chromatography, Odensomoscope, and threshold order number is the measurement for taste and odor. And the temperature, though the temperature is vital, it influences chemical reactions, biological activity, and oxygen solubility. For example, warm water holds less dissolved oxygen, which can stress the aquatic life. We can measure the temperature using the thermometer. And next, moving on to chemical parameters, these are essential for evaluating water safety for various uses. The some of the chemical parameters are dissolved solids, alkalinity, pH, hardness, chloride, nitrogen, phosphorus, fluorides, and other metallic ions. So total dissolved solids. TDS includes all inorganic and organic substances dissolved in water, while water with low TDS taste flat. Very high TDS of above 2000 milligram per liter is not suitable for drinking or irrigation due to salinity. And the alkalinity, this is the measure of the buffering capacity of water, its ability to resist changes in pH. It mainly comes from the bicarbonates and helps maintain a stable pH in aquatic system. And the pH tells us whether the water is acidic or neutral or alkaline. The neutral pH is 7. If it goes below the 7, we call it as acidic in nature. If it goes above 7, we call it as alkaline in nature. Drinking water should ideally have a pH between 6.5 and 8.5. Out of this range, it may corrode pipes or be harmful to the human health. And hardness caused mainly by the calcium and magnesium salts. While not harmful, it causes scaling in kettles and boilers. Water hardness above 200 milligram per liter is considered hard. And chlorides present in water due to saltwater intrusion or industrial discharges. So high level of chlorides can make water taste salty and corrode the metallic pipes. So nitrogen and phosphorus compounds, nitrates and phosphorus phosphates usually come from the fertilizers and sewage. Their excess leads to eutrophication, that means the excess algae growth, which depletes oxygen in the water body. So these are all the measurement techniques used for the different chemical parameters. And the fluorides naturally found in the groundwater in small amounts around 1 milligram per liter. It prevents dental caries, but excessive fluoride of more than 1.5 milligram per liter can cause dental fluorosis, affect the teeth and bones. So let us also touch on the metal and dissolved gases. So non-toxic metals like calcium, sodium, potassium and iron are generally essential nutrients but should be in the acceptable limits. And the toxic metals such as lead, mercury, cadmium, arsenic and chromium are hazardous even in trace amounts. These can enter water from industrial discharges, mining activities and old pipelines. And the dissolved gases includes methane, flammable and dangerous in enclosed system. Hydrogen sulfide smells like rotten egg and is toxic. Carbon dioxide contributes to acidity. Dissolved oxygen, vital for aquatic organisms. Low DO is a sign of pollution, high organic load. Now let's discuss biological parameters which are the most critical when it comes to drinking water. Water can be a carrier of harmful microorganisms such as bacteria, example E. coli, virus, example hepatitis, protozoa, and helminths. These pathogens can cause waterborne diseases like cholera, dysentery, typhoid, and hepatitis. To detect microbial contamination, we use indicator organisms known as coliforms. While coliform bacteria themselves are usually harmless, their presence indicates fecal contamination. So, two standard testing methods are membrane filtration techniques used in lab settings to trap and grow bacteria on selective media. And most probable number MPN test is a statistical estimation of the number of coliforms in water. The coliform index provides a measure of water safety. Ideally, drinking water should have zero coliform in a 100 ml sample. Next, water quality assessment. In practice, water quality is assessed by collecting samples and measuring all relevant parameters using standardized methods. This helps in identifying the contamination source and determining the treatment needed before water can be supplied for different purposes like drinking, domestic, irrigation, or any particular industrial usages. Water quality standards. In India, the quality of drinking water is governed by the IS 10500 2012 standard issued by the Bureau of Indian Standards. It sets acceptable limits, the ideal levels for each parameter, and then permissible limits, the maximum tolerable levels in the absence of alternate sources. Let's look at the few examples. For example, TDS, the acceptable limit is 500 milligram per liter and permissible up to 2000 milligram per liter in the absence of alternate sources. And pH should be between the 6.5 and 8.5 range. And fluoride acceptable limit is 1 milligram per liter and maximal permissible limit is 1.5 milligram per liter. And iron desirable limit is zero point 0.3 milligram per liter due to its staining properties, although it's not toxic. Following these standards ensures water supplied to the public is both safe and potable. To conclude, understanding the water quality parameters and adhering to standards is a key to public health and environmental protection and infrastructure longevity. Thank you for your time and attention.